Good afternoon, ladies, gentlemen, and science colleagues from the States, and good evening for those in Asia region. Thank you, AMS Weather Band, for arranging this Citizen Science Symposium. And we are glad to take this opportunity to share our recent research on next-generation weather observation networks in Hong Kong. I'm Jeffrey Chang, a PhD student from the Department of Geography in the University of Hong Kong. Thank you for my supervisor, Dr. Lucky Lam, for his comprehensive sharing on the synergy of community weather data and numerical modeling in understanding the temperature hotspot and also the extreme heat events in Hong Kong in the previous 15 minutes. Follow with that, in my section, I would like to share our pioneer work in collaboration with the Hong Kong Observatory for the Citizen Science Weather Observation Network, building the next generation public weather observation network with STEM and citizen science initiatives. From the Sustainable Development Goals, we have a high initiative in number 4, quality education, number 11, sustainable cities, number 13, climate actions, and number 17, partnership for the goals. When considering the terms next generation, many of you may think of very fancy ideas like the smart cities, smart robotics, smart industry, etc. Everything goes smart. Are we? From the definition of sustainable development, we emphasize the wordings future generation. The next generation IoT-based weather observation network is very important, while we cannot forget the education framework for the next generation to let them become smart also. A point that the Community Weather Observation Network coincides what was established with the Hong Kong Observatory and now the Hong Kong University in 2007. And in early 2020, our team Urban Climate and Air Pollution Laboratory from the University of Hong Kong have taken over the role and provide assistance to the network. Since the establishment of the network, over 130 local schools and nonprofit organizations had joined our network and installed the weather station at the school rooftops. Let's have a look on the map. Now we only have around 20 stations left in our operation. Why? Are we facing the critical juncture of live automatic weather stations? For this issue, after discussing with the local management team, we heard that the existing automatic weather station has no gimmick. Students get bored to read the number from the console and from the automatic weather stations. We have no resources for our school to support the sensors anymore. How can I do the maintenance after the sensor have been broken? It's hard to link up the automatic weather station with our class material, and it's hard for teaching. Nothing interesting for our network. The sensors have been destroyed in the typhoon season, then what can I do? And the most important question is, how can our students get involved in the weather monitoring station network? To reflect that, we think that STEM and citizen science will be the solution of this juncture. STEM stands for science, technology, engineering, and math in Hong Kong. Under the citizen science program, we encourage students to observe, inquire, plan, analyze, and communicate. Therefore, we plan to adopt the DIY environmental and weather monitoring sensors with open source microcontrollers and software such as Arduino, because those sensors and hardware have low development costs and is very easy to maintenance and with high expandability, which is when we firstly build the thermometer first, and then you can add air pressure sensors the next, or air humidity sensor the next, or even you can add a rain gauge if you can find any appropriate sensors part to add into your system, so that it may be a possible solution to the problem that we are facing now. The meteorological observation is currently rely on the conventional weather station in Hong Kong, operating by the observatory. And the co-wind weather stations with industrial-grade all-in-one package called the Davis Vintage Pro 2 are the setup for the urban monitoring station in Hong Kong now. And in our pilot project, we developed the co-wind 2.0 weather stations with Arduino sensors and 3D printing enclosure. This tailor-made weather station can transmit data through Wi-Fi, LoRa, CB, etc., the communication technologies, and also the sensors can be powered by the renewable energy, such as wind power or the solar power. Then how STEM education program really works in Hong Kong? Actually, we I usually use seminar demonstration of the sensors, organizing some workshops or the sharing sections for the student, or even we can have the field trip, just like in the Department of Geography, we will have the river field trip or different kind of the climate or urban study field trip, then that let the student to explore more on our urban environmental features. With the above concept, we have organized a pilot workshop with 2 sections in September and November 2021. And the workshops provide students and teachers the basic knowledge on Arduino microcontrollers and hands-on experiences for the building their own sensors. After that, we have added a section to assist them for the sensors calibration with the water bath to ensure that the measurement data quality of our data is high enough. And we will also demonstrate the 3D CAD design and demonstrate how to use the 3D printer to design for the enclosures. Before the end of the first section, we ask students to choose a theme in either air, water, or soil to let them design their own sensors closure with different themes and put all the electronic parts, just like the Arduino or the circuitry, inside their own design. And after 2 months, they have returned to our second day workshops and share their experiences and finishing product for their design. And finally, we bought those sensors and portable weather station to go around the campus, and we'll have orienteering in the Hong Kong U campus. Here are some photos during the workshops. We can see that the students and teachers are very engaged in the sensor assembly, and they are very interested in discussing how can they design the sensors or what can they do with different themes, etc. And features are 2 outstanding CAD designs from 2 teams. The first one is from the St. Joseph's Girls College. They have designed a portable air sensors for real-time monitoring. You can also see a different screen with a white color on the figures and also a thermal insulation at the middle of the column. Those designs were considered in their design and making the air monitoring sensors more like in the real time for the real environment and just like more close to the different screen in the conventional weather observation network. Excellent. And follow is the design from the Scout Association of Hong Kong. They have used the material called photosensitive resin to provide a waterproof features to their own designs. Since most of the training sites and also the headquarters are actually in the rural and near to the forestry area. So that's for a waterproof is very important for their own sensors for their operation. After the completion of the design from the teams, then students and teachers are invited to go for weather orienteering in the Hong Kong U campus. There are some task questions to do, and they will also conduct the collocation experiment at different locations in the campus to compare the temperature readings from calibrated automatic weather station from our own laboratory to investigate the measurement bias for their own sensors in the non-laboratory environment. With the real-time data connection, they can also plot the measurement data on the GIS map with latitude, longitude, and also different value in temperature, humidity, or whatever meteorological parameters. And they can also plot the time series and even the Hofmüller diagram to investigate the urban climate with temporal and spatial different resolutions. As most of you are the weather observation expert, I think you may know that doing scientific research in urban microclimate or urban heat island are extremely difficult, as we will never get sufficient and representative measurement from different environments all around the cities. Throughout this pilot workshop campaign, we would like to extend our environmental and measurement network, COWIN 2.0, with the initiative of STEM and science, citizen science education. And we encourage students to take measurement at their schools or their neighborhood to submit data to the network. Of course, they can also use those networks and access them through the data server to conduct any independent environmental or climate science related studies in their home cities. This synergy in science advancement and also education improvement can make this project more meaningful. Notably, these sensors can be used for the development of the smart campus or even the decision making for the individual schools, such as for the for those extreme hot days event, the school can decide whether they need to cancel the physical education lessons or moving the morning assembly to the indoor areas based on the early warning system derived from the forecast, such like in the figures, the urban compatibility index, which was combined from the observation data, from citizen science data, and the machine learning method to conduct some kind of forecast elements. We hope that from our recent research, we can bring you some inspiration on the interaction between quality science education and the expansion of urban meteorology observation network in better understanding our own urban environment. Please feel free to leave any comment, questions, or if you would like to consider any collaboration with our team, please welcome to contact us with the email below here. And for more information about the CoWIN network, please feel free to visit our own website at https://cowin.hu.hk. Thank you for your time.